Hello everyone, welcome to the channel IGCSE and GCSE Maths School. Today also we are going to discuss the paper 1 of Mathematics D of Cambridge O-Level October-November 2023. Now in this paper we have already done 13 questions except the 7th question, and those videos have been included in the playlist created by the name past paper discussion Cambridge O-Level. Then go to the playlist and watch those videos. And today we start from the question 14. Question 14. Now question 14, they have given a triangle ABC, and they ask you to measure angle ABC. Angle ABC you measure by the protractor, and the protractor here, when you measure an angle, yes, this is the baseline. You can find a line is here, this horizontal line. You can find the 90-degree line here, right? Then to measure angle, you have to keep this, then this 90-degree line meets this horizontal line. This horizontal line is called the baseline. Then this point at which this baseline and this 90-degree line intersect is called the center. Then if you want to measure the angle ABC, then you have to keep this center at the point B and keep this baseline on one of the arms of that angle ABC. Then here there are two lines of graduations here, graduations in degrees. Then you can measure the angle from either side, but to measure the angle after you keep the baseline, you have to read from this zero. You have to read from the line starting from 0, not from 180. So it's like this. You keep the center of the protractor at the point B. So this is the angle ABC, this angle. Then you keep the center of the protractor to B and keep the baseline to, I kept the baseline on this BC arm of the angle ABC, right? Then you read from, so you get from this side, then you have kept the, then from the end where you have kept base line on the line, on the straight line CB, and read from 0. That is this, here in this case it is, I have kept the baseline to this straight line CB, and you have to start reading from that line, and from the you have to take the reading from the line of measurement starting from 0. Not because there are two lines of measurements here. One line start from 180, other one start from 0. You have to read from 0, not from 180 time, right? So to keep the protractor like that, and read from the line of measurement starting from 0. Okay. And then write the value here. That is how you have to do. Right. Okay. Then that is up to you to do it. You measure it and write it here. Okay. Next one. They say next one here, part B of question 14. Construct the perpendicular bisector of AC. Construct the perpendicular bisector of AC. Okay. Right. Now, how do you construct the perpendicular bisector of a straight line like this? And this is the, let's say, a straight line segment. You are asked to construct the perpendicular bisector of this one by using the para compass. Then keep the middle point. You keep the middle point here. Take the radius little more than the half of this line. Little more than half of this line. Keep the middle point here. Cut here and cut here and now. Then keep the middle point here with the same radius and cut on the previous two arcs. Then you get two crosses of arcs, and then you join those crossing points of the two arcs, and it will be, that line will be the perpendicular bisector of this line. So like the same thing. Then here they ask you to construct the perpendicular bisector, then AC line. Then here I put the metal point here, take more than half the length of AC as radius in the parallel compass, and keep the metal pointer here and cut an arc here, and cut an arc here also. Then keep the metal point here, and with the same radius cut arc here and cut arc here, right? Then you construct, then you draw the line, that is the perpendicular bisector. Then right, okay, like that. Then what do they ask next? There is a perpendicular bisector line AC, right? Then they ask, shade the region inside the triangle ABC that is nearer to A than C. Right now, look at this one here. We have constructed the perpendicular bisector of the length of the line AC, or side of the triangle AC. Then by this bisector, then this AC side is divided into two equal parts. Then if you take a point here, somewhere here, then if you take a point here, distance from that point to A and C both are the same. Here also, then at any point, from any point on this line, the distance to A and distance to C is the same. So, but now if you take a point somewhere here, that point is closer to A than C. If you put this point here, that point is closer to C than A. If you put this point here, that is closer to C than A. If you put this point here, it is closer to C than A than C. If you take a point here, that is closer to A than C. If you take a point here, it is closer to C than A. So therefore, they say shade the region inside the triangle ABC that is nearer to A than C. Then that point, there's a region or area in the triangle that is nearer to A than C. Nearer to A than means on this line, on the perpendicular bisector, any point on the perpendicular bisector is at equidistance from A and C. That distance is equal. But to nearer to A means you have to put somewhere this region. This region is the that means the region above this perpendicular bisector. Here, everywhere it is nearer to A than C, right? Then and more than 6 centimeters. There are two constraints. One is that that region must be nearer to A than C. Other one is must be more than 6 centimeters from B. Then more than 6 centimeters from B, we have to construct another locus here. Then what is that locus? That is the locus which is 6 centimeters from B. Then if something for B is a point, if there are some points lying some fixed lying some distance away from a point, some distance away from a point, so that will be a circle. The circle is defined as the locus of a point moving at a fixed distance from a fixed point. That is how we define a circle. So then here they say more than 6 centimeters from B. Then what we have to do? You have to draw the construct the locus which is 6 centimeters from B. 6 centimeters from B means it can be here or here. It is 6 centimeters from a point here. Then here it will come a circle like this. 6 centimeters from B means maybe in any direction like this. Here. Then you measure 6 centimeters from this one and draw like this. This with 6 centimeters from this will be a 6 centimeters from B will be a circle. It is a locus of a point moving 6 centimeters from B. Therefore, now what we asked to do is to just identify the region inside the triangle. Therefore, it is quite enough to draw a part of the circle, that is an arc which is 6 centimeters from B. That means you have to take the 6 centimeters as radius in your pair of compass and keep the middle point and draw the line. Let's say that is then draw like this. Right. That is that. We do a what we call arc with 6 centimeters. We do an arc which is 6 centimeters from B. 6 centimeters from B. We draw arc. Take 6 centimeters in the pair of compass, keep the middle point here and draw the arc like this to go through this triangle. And because we ask only the region inside the triangle. Okay. Then, right. Okay. Then we are asked to shade the region nearer to A than C and more than 6 centimeters from. I told you now earlier that now any point nearer to A than C lies above this perpendicular bisection somewhere here. Now there's another constraint, that point must be more than 6 centimeters from B. Then if you take now this is the locus of points moving at a fixed distance from fixed point B through the circle, through the triangle. Then if you take any what we call point inside this area, that will be closer to that will be less than 6 centimeters from B. Then if you take any point in this region, that will be less than 6 centimeters, because 6 centimeters from B is this line. Then within this line, any point this area will be what? Less than 6 centimeters from B. On this, any point on this one will be exactly 6 centimeters from B. Then the area which is more than 6 centimeters from B means this area. All this area, if you take any point in all this area, it is more than 6 centimeters. But there's another constraint, that should be 6 centimeters, that should be more than 6 centimeters from B and should be closer to A than C. Closer to A than C means this area. Then more than 6 centimeters from B means this area. And a common area for both those areas will be this part within the triangle. Oh. Right. That is it. Then go to the question 15a. There's a linear sequence. They say Q15a says that there's a linear sequence. Its second term, T2 means second term, is 28. And its T5 means fifth term is 60. They say, what are the linear sequence? Linear sequence is always a sequence. That is a sequence that there is a common difference between every pair of consecutive terms. There is a common difference between every pair of consecutive terms. Now, for example, now say now take like this 5 now take 5, 7, 9, 11, 13. Thus this one is now see take the difference between every pair of consecutive terms here to here. 5 to 7, 2, 7 to 9, 2, 9 to 11, 2, 11 to 13 also 2. Now see, there's a fixed common difference. That's called constant common difference. So common difference, fixed difference is there. Common difference between every pair of this is what? Linear sequence. That is the main property of the linear sequences, is that there is a common difference, that is fixed difference between every pair of consecutive terms, right? That is the what we call linear sequence, right? Okay. Now they say that this is, then here say that this there's a linear sequence. Its first term is 28. Sorry, its second term is 28. Its fifth term is 16. Then we are asked to find the first term, third term, and fourth term. Then we first of all, if you know, now let's say if you know that, say, if you know that, let's say, if you know one term, then the third term, let's say, T3 of something. T3 is of something, of a linear sequence, of a linear sequence. Let's say given as 9. They give the common difference, otherwise they name as D. It is denoted by the common difference as 2. Then we can write this sequence. Then T3, T3, T2, T2, T1. Okay. Then from this one, we can write T3. We have T3 is how much? 9. Then from this side, you can get the common difference is 2, and as common difference is plus 2, you have to go and add it. Then 9 plus next term is T4 is how much? Adding 2 to 9, 11. T5, adding 2 to 11, that is 13. Then T2 will be, then you get 9 by adding 2 to T2. Then T2 will be 9 minus 2, how much? 7. Then T1 will be 7 minus 2. That means how much? 5. So this is how you can build up the linear sequence when you know whatever term, whatever one term and the common difference. So like that, if you know the common difference and here they have given 2 terms, then we can find these terms, right? Okay. So we will find the common difference. To find the common difference, you say here T2, they give T2, T3, T4, and T5. But they have given us how much? They have given a T2 as 28. Then T5 is 16. Now you can see that T2 to T5, the sequence has decreased. There's a decrease in sequence. This decrease in linear sequence, it has decreased with terms have decreased with a common negative difference there, right? Okay, that means common difference divided from 28, common difference divided from T3, common difference is deducted from 4th term, and you get the 15th term. So then how many differences we can find? From here to here, 1 difference. From here to here, 1 difference. From here to here, 1 difference, right? 1 difference, the same difference. If it is difference is 2, here to here to here. There are 3 common differences here. 3 common differences. Therefore, if you take the difference between these 2 and divided by 3, then you can find the common difference. Then we first of all, D equals how much? 28 minus 16 and divided by 3. How much? 28 minus 12. Then 12, right? Okay, 16. 2 minus 1, 1. Okay. Divided by how much? 4. That is 3. Okay. Then common difference is, sorry, that's wrong, because here total of the differences here 12. The sum of the differences is 12. There are 3 common differences here divided by 3. Then you get 4. Then 4 is the common difference, D. If you know the common difference, you can write all other terms, right? Now we will write the other terms, right? This is the common difference. Okay. Now we will write the other terms here. They gave us T28, no? Then T2. They give they also T1, no? Then T1, T2, T3, T4, T. That's all we want to find, right? Okay. Now we know T2 is 28 here. Then from T2 to T5, sequence has decreased, no? Sequence has decreased. Therefore, this common difference is not just 4 but minus 4. That's this. By common difference, terms have decreased. Therefore, 28, second term is 28. Then third term will be 4 less than this, how much? 24. That 4 less than this will be how much? 20. You deduct another 4 from the 20. Then that is right. Okay. T4 and we are finding T9. We get this by deducting from T1 4. Then to get this one, you have to add 4 to this one. Then it will be 32, like that. Okay. So they are the answers T1, T3, T4. Okay, they are the answer for that. Right. Now we go to next question B. I will erase this because there is a problem with space. Otherwise, I can do here, right? Right. Right. Okay. Now this B part of question 15. 5 terms of different sequence are 3, 9, 19, 33, 51. Right. Then 5 terms are 3, 9, 33. Sorry. 3, 9, 3, 9, 19, 33, 51. Okay. So these are 5 terms of different sequence. Right? Okay. This 90. Okay. This 90. Okay. 3, 3, 9, 19, 33, 51. Right. So they are the 5 terms of a common difference. First 5 terms of a common difference. Right? Okay. Now, sorry. These are first 5 terms of another different sequence. Right? Okay. Then they ask find the expression for the nth term. They ask you to find the nth term, this B part. You ask to find the nth term for the sequence, right? Then, now first of all, we'll see we don't know whether it's a linear sequence or a different type of sequence. Now, first of all, if a linear sequence, we can apply this. Find that. If then first of all, we have to check whether it's a linear sequence or a different sequence. In a linear sequence, I told you the main conspicuous property of linear sequence is that it maintains a common difference between every pair of consecutive terms. If you get the difference between every pair of consecutive terms, it will be a constant value. It should be a fixed value. Fixed difference between every consecutive term. See whether it is there. Here it is how much? Difference is 6. Here difference is how much? Is 10. Here difference is how much? 13, 19, 13, 14. Here difference is 18. 6, 10, 14, 18. Now here the differences. This is then differences between consecutive pairs of consecutive terms are different. Therefore, it's not a linear sequence. That is the first thing that we are doing. It is not a linear sequence. Then we have to follow a different method, right? Right. Then here, then we can't, as this is not linear sequence, we can't follow any of these. What you call we can't find. And if we go to a linear sequence, in a linear sequence, n term is found by using this a plus n minus 1d. You apply this to find first term and the common difference and get the nth term. But this can't be applied for this one because why? This is not a linear sequence. This is something else. Then we have to go into that and find a different way to get the nth term. Right? Okay. Now here this is the first difference. First difference. Then the second difference you will check. Second difference is 4. That is a constant. Right? If the first difference is not a constant, and if the second difference is constant, it is a quadratic sequence. What is that? Quadratic sequence. What is it? If the quadratic sequence, then if it's a quadratic sequence, the first difference is not a constant, but first difference is a linear sequence. But the second difference is what? Constant. That is how you identify whether given sequence is a quadratic sequence. So first difference is a linear sequence. Here, linear sequence is anything like this. Here, the linear sequence. This what we call first difference sequence of first difference is a linear sequence. See, here it has a common difference. 4, 4, 4. Then second difference is a constant. If these two conditions are satisfied by a particular sequence, it's a quadratic sequence. Now, if it's a quadratic sequence, we can apply this one, two methods. Method 1. Method 1 use this common format plus ax squared plus bx plus c. Other one is a different method. Another method 2, that is a plus n minus 1 d1 plus, you apply this formula, d2 over 2 n minus 1 n minus 2. So that is that formula. One of these two formula can be used. I will do in both the methods and show it. Right now here a means here this is called first differences. This is called second difference. A is the half of second difference. A equals what? Half of second differences. Second difference. Right. Then here C is the zeroth term. Zeroth term of this sequence. Zeroth term we will find now like this. Here this difference here is 6. Then difference between this difference and this difference must be, there must be difference. This is first term, second term, third term, fourth term. Then this will be zeroth term. Zeroth term will be here. We will find this difference first. This difference. Then that will be 4 less than 6, because this one is 4 more than this. Then this one will be then 4 less than 6. That means 2 less than 2, right? Less than 2. Then that 2 is deducted from this one, because now here they have this you get 9 minus 6 3, then 10 minus 99. Therefore 3 minus 2 will be this term 1. Okay, right, that is the zeroth term. Then we will substitute into that this one. What is the half of second difference of half of second difference means here second difference is 4. Half of 4 here 2. 2x squared plus 2n. Now n means the number of terms, right? 2n squared, then plus bn, then plus zeroth term 1, like this. Then to find b, we substitute one of these terms. Let's say this is equal to one of the terms here. Let's say let's say 9, right? Then 2n. Now we are going to substitute. To find b, we are going to substitute one of those terms with its n value. N value is this. Then we are going to substitute this one. Then what is this? Let's say 9. This is the term. If the term is 9, 2 into n is how much? Second term. Put 2 here. Squared plus b we don't know. N is 2. N is 2. Then plus 1. Okay. Then you write here 2 squared is how much? 2 squared is 4. 4 times 2 8 plus 2b plus 1 equals. Then 8 plus 1 is 9. Then 2b equals 9 minus 9. B equals how much? 0. Because 9 minus 9 is 0. 0 divided by 2 is b. Then there's no b term. Then we can apply this one here into this one. Then 2n squared plus bn plus 1. Then b value is 0. Therefore 0 times n 0. Therefore you can get the answer tn squared plus 1. That is the n term of that one by using this now. Now here a is the first term. First term is 3. Write it 3 here. Then plus n minus 1. Then d1. D1 is the first difference. This is the first differences. Out of them, the first difference is this 6 plus D2. D2 is the second difference. Second difference is 4. 4 divided by 2 is 2. then n minus 1, n minus 2. Okay, now you simplify. Here 3, then here 6n minus 6. Then you multiply by 6 to remove brackets. Then here this one will be 2. This one will n into n squared. Then n into minus 2n, minus 1 into n minus 3n. Then minus 1 into minus 2. How much? Plus 2. Okay. Then you remove brackets. Here 3 minus 6 how much? Plus 3 plus 2 here. 2 n squared. 2 minus 6 n 2 into minus 3n is 6 minus 6n, then plus 4. This cancel. Then here it is 3 minus 6 is minus 3. Sorry, minus 6. Then here it is 2x squared. Sorry, 2n squared. 2n squared. Here minus 3 plus 4 plus 1. Right. Okay, the same thing. That is the nth term. Now come to question 16. The question 16, they say part A, they say find the value of t. They have given this question says t equals square root t minus 4. Then A part says work out the value of t when t equals 40. Then you write t equals p minus 4. Then substitute this part A. Substitute this p is 40, 40 minus 4. Then t equals the 40 minus 36. 36 square root 36 equals how much? 6. Okay. Then part B, they say make p the subject, right? T equals, you write first of all the formula p minus 4. Make p the subject. First of all, remove the square root this side. When square root comes, it becomes square. Then t square equals p minus 4. Then take minus 4 is a plus 4. P squared plus 4 equals p. Then p equals p squared plus 4. So that is the formula after it is transposed for t. Right. Have a nice time. We end the video here and have a nice time, and we will meet in another interesting video next time. Thank you very much.